Hello everybody, today we're going to be looking at 1.3. I'll be going through the warm-up and the regular lesson, and also maybe a couple of the huddle problems, because it's not a very long lesson. So let's start off with the warm-up. We're looking at the table and some graphs to see if they are considered functions, and why or why not. We'll have a little explanation. If we look at the first example, we have 1, 2, and 4. We look at the x values to see if they repeat, and if they do not repeat, that means it is a function. So we can say yes, it is. And we could say no x values repeat. And that's all you need as an explanation. Number 2, you're looking at graphs. And so we use something called the vertical line test. Draw it straight down. It only ever crosses one time every time. So this is also a function. What can we say here? Simply that it passes VLT. And the last example, if you draw vertical lines, it crosses 2 times every time you draw a line. And if it ever crosses more than once, then we immediately say, no, not a function, because this actually fails the VLT, vertical line test. Just a warm-up, not too bad. 1.3, how do we read and write using function notation? And that's the name of the lesson, function notation. Let's go to example 1. Solve 5x plus 2 when x is 3. So what is this asking us to do? It's asking us to see where x is here. And they want us to replace or substitute 3 in for the x. That's easy enough. 5 times 3 plus 2. Then apply PEMDAS. You get 15 plus 2 or 17. Now, if we look at that and compare it to part B, we have some kind of new notation here. Hopefully you know how to read this. You do not read this by saying if f times x. It's not multiplication here. It's a different form. It's called a notation. They call it function notation. And the way you read that is, if you remember, f of x. When a number is there instead of x, we substitute the number in for x in the expression. So it may look different in part B, but it actually does the exact same thing as part A. Same exact thing. It's just substitution. So we're going to look at this and read it like this. If f of x equals 5x plus 2, then find f of 3, is what that says. So we start out with f of 3, and that's just basically saying, hey, there's an x in here originally. I want you to place the x here with 3. And also, you replace any other x you see over here with the 3 as well. So on the left-hand side, we copy that down, f of 3, and we replace this with 3 as well. So it's 5 times 3 plus 2. But now we actually have like an equation going. We keep the f of 3 on the left-hand side. On the right-hand side, we evaluate. This is where we get our 15 plus 2. Or as we know from the other example over here, it's 17. So now we have an answer where we can see what the input was, and then we can see what the output was. So it is kind of advantageous to look at functions like this and say, oh, this is f of 3. Oh, we put 3 in for x, and that's kind of our y value here. Whereas this here, you do the problem, and that's all you have is 17. So it's a little bit more advantageous to see what was going on. This is called function notation. So let's practice just writing it out in words so that we don't forget how to actually say this. So I'm going to write this out. When we look at this, this is a of x equals 90 minus x. So a of x equals 90 minus x. I'm not going to write out everything in words. We just got to get the idea of how do you read this out loud. Please, please, please don't say a times x. Number 2, you would say this is t of x equals, and then 1.8x plus 32. Again, don't have to write that out in words. And the last one would be Q of G equals 15G minus 3. Just practice. Oh, I completely forgot. I did not write it out. Q of G. There we go. That's how you say this here. Make sure you're familiar with how to say it. So whenever we do it in class, you can say the right thing. So we're going to practice a little bit by substituting in different numbers. So example 3, it says if T of C equals 1.8C plus 32, let's evaluate at different numbers, as you can see with A, B, and C. So A, they want you to evaluate it at 20. So that means you plug 20 in here, and you also plug 20 in over here. So we start off the left-hand side of the equation and say T of 20 equals 1.8 times 20 plus 32. It's getting a little sloppy here. And then you just use your calculator. The left-hand side, again, stays the same. You're not evaluating anything over here. Man. The other side, you have to actually multiply together and then add. So go ahead and do that. We do 1.8 times 20. That is 36 plus 32. So as a final answer, we get T of 20 equals 68. And that would be your answer. All right, we're going to try another one. We're going to plug in 5. So same idea, just copy this down and plug in 5. So, oh goodness. T of 5 equals 1.8 times 5 plus 32. Then use your order of operations, put 1.8 times 5. That is 9 plus 32. So the final answer, what would that be? 41. And that's your answer. T of 5 equals 41. The last one looks a little different. It actually wants us to evaluate T of 20 and then evaluate T of 5. So it's actually like two problems in one. You would do the first one, get a number, do the second one, get a number, and then after that you would subtract them. But luckily we don't have to do all that work, because if we look at A and B, look what we already found. We know what T of 20 is. It's down here. It's 68. So I'm just going to substitute the entire thing with the number 68. Right? Because down here it says T of 20 is 68. So replace that with 68. Minus, what's T of 5? Well, that was right here. That's 41. If we did not already have these evaluated, we'd have to do each one individually and then subtract. This actually makes it pretty easy. And so that would be 27 when you subtract. And that would be your final answer. Okay, moving on. So there is another notation. It's called mapping notation. And we're going to write out in words how you would say the following. So the first one we already know how to say. This is f of x equals 3x plus 7. This one's a little different. Oh, it looks very different. However, they actually mean the same thing. These are equivalent, these two things. It's called mapping notation. So let's go over that down here. Instead of being written as f of x, it is this f with a colon, x, and then an arrow. And how you read this is, going in order here, you say f, and then the colon is the word maps. Then you read x, and the arrow is onto. So if I was going to read this one out loud, I would say it's f maps x onto. That's what this word is. Kind of goes like this. And then 3x plus 7. There's no equal sign at all. There's no parentheses. F maps x onto. It's another way of doing the exact same problem. And we'll do one to show you how that works. you would substitute numbers in for the x's here. Example 5, change the following to mapping notation or function notation. So we're going to kind of go back and forth between the two. So let's start with a mapping here up top. This is g maps x onto 12 minus 2x. So we're going to change that to g of x equals. That takes care of this entire thing. And then it's just 12 minus 2x. Go in the opposite direction. We're going to start with function notation. F of 7. So we're going to rewrite it as f maps 7 onto. That takes care of this whole thing. And then write the rest. 5 times 7 plus 4. This notation is probably something you have not seen before. All right, let's do it again. Going from g of x over to mapping notation. So we say g maps x onto negative 3x plus 9. And lastly, we'll go from mapping to function notation. This would be g of, what number comes next? 4 equals 8 plus 4 times 4. So this end part you just copy down after you get past the equal sign. All right, moving on. Example 6. The table below shows the year X and the cost of a gallon of gas in cents, C of X, that's how you read that, during the year X. So here's your years going across. And down below is, what does it say? The cost of a gallon of gas in cents. So if you were going to go to dollars, you'd have to move the decimal place over 2 times. So this would be like $1.23, and so on as you go up. So right now they're just doing it in cents though. So 123.4 cents. All right. Actually, when you have a table like this and then doing this notation down here, it actually makes things really easy. So we're going to evaluate C of 2006 minus C of 2005. The way you do that is you're just going to be looking at the table for the values. We're not going to be doing any kind of evaluating of like trying to solve an equation. None of that. We're going to be looking at 2006, because originally it's like this, C of x. So what they did is they changed the x out to change it to 2006. So we're going to find 2006 on the x table. It's down here. And they want us to read C of 2006. Or in other words, we're going to look at the cost of cents of gas. So we just go down, and here it is. That's the number. No actual math, just looking at the table and reading it. So this whole thing is the number 258.9. And we're going to subtract that from C of 2005. So we look at 2005, find that as the x value right here. And the value that it is at C of x, or C of 2005, is 229.5. And then you take your calculator and you just subtract them. So go ahead and do that. When you subtract them, you get 29.4. And this, as a unit, would be cents. Okay, so explain what we calculated here. So what did we actually find? We took 2006 and we found the price of it. And then we found the price in 2005 and we subtracted them. So what we found here as an answer is we found the difference in price. This isn't cooperating too well. And gas price from 2005 to 2006. That's what we calculated. We found how much did it change from 2005 to 2006. Part C, what does your answer to part A, so the answer we got here, tell you about the price of gas in 2006? So what happened when we went from 2005 to 2006? We can say specifically that the gas price went up. It increased because we got a positive number, and it went up by almost 30 cents per gallon. So price of gas, it's not working out too well here, increased, that's pretty important to say, by about 30 cents per gallon. We can stop there. 30 cents per gallon. Maybe I could also add, if I were going to add a year, the price of gas increased by about 30 cents per gallon from 2005 to 2006. There we go. Try to get as detailed as possible to know exactly what's going on. And this is actually something where I would want you to be detailed. So you should be able to explain, okay, so we know the price of gas increased by 30 cents, close to 30 cents per gallon from 2005 to 2006. Use as many numbers as you possibly can and make a sentence out of it. So that is everything. We're going to go through a huddle problem or two. Let's go through the first one here. We have let f map x onto square root of 5 squared minus x squared. Answer the following. We're going to rewrite this in function notation. So we're going to write it as f of x equals the square root 5 squared minus x squared. And then we're going to actually plug in some numbers here. We're going to find f of 3 and f of 4. So f of 3 would be the square root of 5 squared minus 3 squared. Again, the left-hand side stays the same. So let's go ahead and do our exponents. That's part of the order of operations. We have 25 minus 9. What does that give you? That would be 16. And the square root of 16 is actually a nice number. It's 4. That's your answer. You should be able to do that from here. So I would say pause video, try this one, see if you can get the right answer. I believe the answer comes out to be, I think it's 3. And number 2, I'm just going to do a quick overview of this. What is the value of the function v when r is 6? That's just telling you to plug 6 in here. So you're doing v of 6, 4/3 pi times 6 cubed. That just means 6 times 6 times 6. And then you evaluate this left-hand side, and you'll eventually get an answer here. So I want you to try that as well. 3, let t map x onto 2x plus 4. Evaluate t maps 2. It's a weird way to say that. So here they want you to actually plug in 2 into the x values. And if we're going to use the same notation, it would be t maps 2 onto 2 times 2 plus 4. So, whoops, put f. It's t. T maps 2 onto, and you're just going to evaluate this, becomes 4 plus 2, or plus 4, which is 8. And that would be your answer. There's only a couple left. I think I want to go over 6 and 7. This one is very similar to the one we just talked about with a gallon of gas. This is just writing out in words, right? R maps S onto, and you can do that here. Write it out in words. 6, let R of C equal 2C plus 10 over C. Rewrite the function using mapping notation. That's not too bad. R maps C onto 2C plus 10 over C. That's all that one is. We're going to find R of 6. So now it looks like they want us to use the original notation to find it. So R of 6 would equal, you plug in 6 wherever you see C's. 2 times 6 plus 10. And the bottom is also 6. Then just do your normal order of operations. 2 times 6 is 12 plus 10 over 6, which would give us, it's not going to be a nice number, 22 over 6. Although it does reduce, you can divide them both by 2. You can get 11 over 3. So as a final answer, I would say it's R of 6 equals 11 thirds. Or you could divide it and get 3.6 repeating. Part C, why is R of C, so this function up here, why is it undefined when C equals 0? So think about what happens when you would plug in 0 to these two spots, right? What if we chose to use 0? So it'd be 2 times 0 plus 10 all over 0. Think about what's the problem with this setup here, and then you could answer it. And part D is a challenge. Find C when R of C equals 12. So they're telling you the left-hand side of the equation is the number 12. So I'll help you set it up. R of C is 12, so that means you're going to replace R of C in this equation on the left-hand side by changing it to 12. So 12 equals, the other side, we don't know C, so you got to find it. And I'll leave that to you to finish to find. Eventually, you got to do some work, get rid of the fraction and everything, and you'll eventually get C equals something. And the last problem I want to go over is, the last one that's on here is number 7. Plumber charges $80 per service call plus $65 per hour. Describe this situation using function notation. So let's pick something. Let's just say, pretty common one is f of x. F of x equals, well, let's look at this. Let's see what's changing. $80 per service call, so it's $80 you're starting out at, plus, this is kind of like the one we did with the chart. When we talked about Logan and his iPod, he's adding songs. We remember we kept making expressions for that. It's the same idea. So we look at this, we're starting at $80 for every call, but then you get paid $60 per hour. So this would be plus $65 for every hour, so times X. And if we wanted to label this, we could say, hey, so X stands for hours, right? So depending on the number of hours will depend on how much money they get for working. The plumber gets so much money depending on how many hours he works. So it's $80 just for the service call, and then $65 per hour on top of that. Part B, how much does the plumber earn for a 5-hour service call? So that just tells us to plug in 5 for X. So we do F of 5 and plug it in. 80 plus 65 times 5 hours, and we said X was hours, so times 5. And I'll leave this one to you to finish. You multiply and add and see what you get. So I did most of the entire set of notes for 1.3, and hopefully it wasn't too bad for you. And if you have any questions, so next time I see you, we can answer them and go over them. But I think it wasn't really that bad, and not a lot of new things. Really, the only new thing is the mapping notation. And you should be able to finish the notes from there.